हेलो ठीक अनम्यूट नहीं डायरेक्ट वेयर करना है
E, P, F are perpendicular to each other. Data sample. See, we have initially Lorentz force as F bar is equal to V bar cross V bar. So the direction of force will depend on the directions of V and B. So V bar to V bar as a rotation होईल. So right hand screw rule you have to apply. So if the rotation is from V bar to V bar, then the third force will be perpendicular to both V and B. So this is mutually perpendicular case. So if this is velocity, this is the magnetic field. You placed a particle in field which is moving towards me, that is in this direction. Your force acting on the particle will be in upward direction. And so, ठीक है. अजून काय डाऊट होता लास्ट लेक्चर मध्ये तर त्याला एक्सपांड करून आपण करतो एफ बार इज इक्वल टू और एफ इज इक्वल टू व्ही इंटू बी इंटू साइन ऑफ थीटा वेर थीटा इज द एंगल बिटवीन बी बार एंड बी बार. It will be maximum, the force will be maximum when both are perpendicular to each other. That is, maximum value of sine function is 1, sine 90. Velocity's a component can be resolved into two components also. but त्याच्यावरतून तुमचा helical motion आला. Okay. So last lecture we have studied the Lorentz force, that is magnetic force acting on a particle. Cyclotron motion, which is used in cyclotron accelerator, and helical motion. Okay. So today we will see about magnetic force on a wire carrying a current. Suppose we have a wire in which the current is flowing in a particular direction, then we have to find out the force acting. That is magnetic force acting. So the shape of the wire, we can consider two cases. First, we will consider the wire is in straight shape, and the second, it is shaped very arbitrary. Okay. So for the first case, see, we have seen earlier the Lorentz force, and from this equation, we will find out the value of the force. The first case is straight wire. Okay. So for straight wire, consider any straight wire of length capital L, which is shown in your textbook. नाही सापडत आहे कसं आहे magnetic force on a wire carrying a current. So see the diagram 10.8. मी तर ती काढतेच त्याच्या आधी ती diagram. That horizontal cylinder is your wire. Okay. We have to consider only capital L much of length. So consider a straight wire of length capital L and external magnetic field B is applied perpendicular to the wire and coming out of the plane because dots are shown over there. So here the magnetic field is coming out of the plane of the field. Let a current I flow through the wire under an applied potential difference. So if Vd is drift velocity of part of length capital L, then the charge flowing in the region P. Region this the P. This is the wire of length capital L. Current I is flowing in this direction. Field is coming out of the plane of the paper. And consider the region. Okay. So see, if the current flowing through this wire is I in time, let's say small t, then the total charge is Q is equal to charge चा formula आहे current into time, right? Charge calculate केलं पाहिजे. आपल्याला लॉरेंस फोर्स मध्ये काय आहे F is equal to Q into actually the force is Q into V bar cross theta. It will be Q V sine of theta. Charge is important here. There are no charges present. It is the current flowing in the conductor. So from that current flowing in a particular time, we find out the charge. That is Q is equal to I into T. So that is T. Time साठी त्यांनी काय दिलं? Equal to I. Time is velocity and time से relation. If the electrons are moving with the drift velocity, velocity is distance upon time, right? So time is distance upon velocity. Distance is L, means L length of conductor मध्ये electrons or charges are moving with the velocity Vd. So this is your Q. I into L into Vd. Clear है? As we are considering charges, we want charges, but here the current is present, so we have to take into account the drift velocity of the electrons. Next, the magnetic force Fm on this charge according to the Lorentz force is formula लिहायचा Lorentz force चा काय formula? That is magnetic. So it is Fm bar is equal to Q into V bar cross E bar, right? Here the velocity we are considering as the drift velocity. The value of Q from this equation is I into L upon Vd, right? V bar cross V bar कैसे लिखा? Vd into this field B and angle for the cross theta will be sine, cross product will be sine theta. ठीक है? आणि n cap त्यांनी introduce केलेला where n cap will give you the direction. काय डाउट आहे? क्लियर आहे इथपर्यंत फॉर्म्युला? आता मला सांगा field is out of the plane of the paper. Velocity of charges will be, is this perpendicular? ठीक है? So sin theta मतलब theta will be 90 degree. So theta is angle between B and Vd. Velocity and field. Field is out of the plane of the paper. Velocity म्हणजेच current direction flow through. This is the velocity. Angle between these two is 90 degree. That is both are perpendicular. So I L Vd will get cancelled. is maximum, that is sin 90 meter तरी झाले. That is equal to I into L into D. ठीक है, n cap is giving you the direction because अपन इधर तो वेक्टर दाखवला है, it is the direction of the beam. Where n cap is a unit vector perpendicular to both B and B, that is n cap is in the direction of the force. So it is perpendicular to both VD and B, and Fm you can simply write it as I into L into B into n cap. This is the vector form of the magnetic force acting on the wire, which is in shape having length capital L, and charges are moving with the drift velocity Vd. This is therefore magnetic force acting on the portion of the straight wire having length L. So if V bar is not perpendicular to the wire, if this V and B are not perpendicular, there can be some another angle rather than the 90 degree, which is not zero. If it is zero, the force will be zero. ठीक है. दूसरा काही angle दिला असेल तर जनरलाइज फॉर्मॅट मध्ये कसं देणार? So if theta is not equal to 90 degree or it is not perpendicular, then the magnetic force is given by I L. L bar cross V bar. Length चालंगच घेणार ना आपण. I into L bar cross V bar. So L bar cross V bar will be the angle between length and the magnetic field. Length म्हणजेच काय, त्याच डायरेक्शन मध्ये करंट फ्लो होणार. This is your magnetic force acting on the wire. Fm is equal to I into L bar cross V bar. Bracket करेगा. So second case, this was about the straight wire. So if it is arbitrarily shaped wire, that is, it can be like this. माहिती नाही आहे त्याची. ठीक आहे. मग लेंथ कशी कॅल्क्युलेट करणार? तुम्ही स्केल अशी नाही ठेवू शकत. You cannot calculate the length. We have to consider very small portion. Let's consider this length as a dl. Okay. So for this dl, force will be very small in magnitude. So the total magnetic force acting on this will be I as it is. जिथं L घेतला होता L bar तिथे आपल्याला घ्यावं लागेल integration of dl bar cross. Rest of the formula is as it is. We just have to integrate the length because small portion घेणार आपण integration from 0 to the total length. So it is I into integration of dl bar cross b. हे काय कळालं? Arbitrarily shaped wire होतं. Initially we will consider very small amount of length and lastly we will just integrate over the whole length of the wire. This is the magnetic force for the arbitrarily shaped wire. That's it. याचं डेरिवेशन वगैरे काय कुठं लागत नाही, त्याच्यावर फोकस करण्याची गरज नाही. काही डाऊट आहे याच्यामध्ये? दिस इज अबाउट मॅग्नेटिक फोर्स ऍक्टिंग ऑन ए वायर कॅरिंग ए करंट. फॉर स्ट्रेट वायर द फॉर्म्युला इज I into L bar cross B bar. Theta will be given between length and the magnetic field, and if the shape is arbitrary, then you have to take its integration over the whole surface or over the whole length. Clear it? Next one. Force on a closed circuit in magnetic field. Force on the closed circuit मध्ये Gauss law आठवते sphere वाला case. If we are considering sphere, that is conducting sphere, the whole charges are accumulated on the surface. So inside there is no charge present over there. Inside, तिथे आपलं इलेक्ट्रिक फील्ड काय येत होतं? 0 क्लोज सरफेसच्या आतमध्ये. जिथे चार्जेस प्रेझेंट नाही, बस तोच इथे अप्लाय करायचा ट्राय करायचा. सो सी फोर्स ऑन ए क्लोज्ड सर्किट इन ए मॅग्नेटिक फील्ड. इफ दिस वायर एंड बेंडिंग दिस वायर इनटू द शेप ऑफ द सर्कल, ठीक आहे, तर मग करंट त्या वायर मधून फ्लो होतं. आतमध्ये आजच कुठले चार्जेस और करंट प्रेझेंट नाही. सो इक्वेशन 10.17 this can be extended to a closed wire circuit, let's say C. So Fm will be, we have to take closed loop. काय होईल ना मॅग्नेटिक फोर्स विल बी इंटिग्रेशन ओव्हर अ क्लोज लूप. करंट पण चेंज होईल तुमचा इंटिग्रेशनच्या आतमध्ये जाईल. I into dl bar cross this is integration over a closed surface. तर पूर्णचं इंटिग्रेशन घ्यायचं. Here integral is over the closed circuit C. So for uniform B, या केसमध्ये magnetic field will be obviously uniform. तरच हे होणार आहे, otherwise it will have circle. So if your field is uniform, then current and magnetic field will be outside the integration. त्याचं integration घ्यायची गरज नाही. So if B is uniform, then magnetic force will be I integration over a closed surface dl bar cross. ठीक आहे.
आधी पण ते इंटिग्रेशन
बी बार पण बाहेर काढला युनिफॉर्म आहे आता तो दॅट इज कॉन्स्टंट करंट इज ऑल्सो कॉन्स्टंट बी बार कॉन्स्टंट असेल तर करंट कॉन्स्टंट आहे पहिल्यांदा मी जनरलाइज केलं जनरलाइज इक्वेशन दिला मग सांगितलं इफ बी बार इज युनिफॉर्म देन यू कॅन डू दिस इफ बी बार इज नॉट युनिफॉर्म देन यू हॅव टू integrate the whole. So the term in the bracket, this integration over a closed surface dl bar, it's sum of vectors along a closed circuit and it will be zero if it is totally closed. So magnetic force acting is and हे तुम्हाला MCQ मध्ये खूप frequently विचारतात बोर्ड्स मध्ये. Integration over a closed surface of the length over a closed circuit is always zero. So the total magnetic force is zero. राहील लक्षात जिथे जिथे विचारतील मॅग्नेटिक फोर्स फॉर ए क्लोज्ड सर्किट देन इट विल बी झिरो. नेक्स्ट टॉर्क ऑन ए करंट लूप. टॉर्क आठवतं कशामध्ये पाहिजे इलेक्ट्रोस्टॅटिक्स मध्ये कुठल्या टॉपिक मध्ये पाहिलेला डायपोलच्या डायपोलला दोन पोल्स having same magnitude distance is constant throughout. So when you are going to place this dipole in an external electric field then the forces on the dipole will act in equal magnitude but in opposite direction, that is forces will be in couple, that is nothing but the torque. ठीक आहे सेम टॉर्क बघायचं इथं. तुम्हाला टॉपिक आठवतं एसी जनरेटर काय होतं त्याच्यामध्ये कन्स्ट्रक्शन हॉर्सशू मॅग्नेट होतं और दोन पोल्स ऑफ मॅग्नेट येस याच्या बिटवीन एक रेक्टँग्युलर कॉइल और वायर ठेवली होती आणि कार्बन ब्रशेस आर देअर. काय काम होतं व्हॉट इज द रोल ऑफ कार्बन ब्रशेस कंडक्ट कर रोटेट होऊ शकते. अजून मग काय व्हायचं करंट फ्लो व्हायचा रोटेट व्हायचा बिकॉज करंट जाणार आहे मॅग्नेटिक फील्ड मध्ये. ठीक आहे तर मी डायग्राम काढायचा ट्राय करते. बरोबर आहे राईट करंट इथून फ्लो होईल असं जाईल. तो तरी तर काय होणार आहे देयर आर टोटल 4 आर्म्स और लेग्स. ठीक आहे इन ईच अँड एव्हरी आर्म द डायरेक्शन ऑफ द करंट इज डिफरंट. सो कुठला कॅन्सल होतं का दिस अँड so for this current and magnetic fields are parallel. This is the direction of magnetic field and for these two arms this is direction of current, either it is parallel or anti-parallel. So as I current and field B are parallel or anti-parallel, force acting here will be zero. Kasa parallel means theta will be zero, sin zero is zero, anti-parallel means theta will be sin 180 zero, force will be zero. So we will not take into account these two forces or the forces acting on these two arms, right? आता राहिले कुठले हे दोन दिसतात which are perpendicular to the direction of the magnet. So what happens here? This is field, this is current. इथं नाही शिकवत आहे. Field बघा N2S सपोज चाललेलं आहे आणि ही कंडक्टिंग वायर. सो फील्डला दिस इज परपेंडिक्युलर, हे आणि हे कॅन्सल झाले सांगितलं मी तुम्हाला. दिस इज वन आर्म, दिस इज सेकंड आर्म. कसं रोटेट करायचं? व्ही बार क्रॉस व्ही बार. व्ही बार इज द वेलॉसिटी म्हणजे ते मूव्ह कसे होतात, करंट मूव्ह. दिस इज व्ही बार, दिस इज व्ही बार. व्ही बार क्रॉस व्ही बार. फोर्स कसा ऍक्ट होईल? व्ही बार टू व्ही. समजतंय? लक्ष द्या सोबत. This is the V bar. This is V bar. So V bar cross V bar. Current force act होईल या आर्म वरती. It is in the upward direction. Upward direction. इथे upward असेल सेम केस मध्ये इथं. This is V bar and V bar. V bar cross V bar. So या आर्म वरती force will be in upward direction. For this it will be in downward direction. So हा असा इतकाच मूव होतो. बस that's it. ठीक आहे. नाउ हा आर्म इथे होता ना जेव्हा तो वरती जात होता, पण आता इकडे आल्यावर त्याचा करंटचा डायरेक्शन उलट आहे. सो अगेन द फोर्स विल ऍक्ट ऑन बोथ द आर्म्स इन ऑपोजिट डायरेक्शन. हेन्स देयर विल बी रोटेशन. रोटेशन झालं तर पुढे काय होतं? नाही आठवत. हा, ते डिव्हाइस असतं ज्याच्यानी सायकल्स विल बी देअर. एसी जनरेटरचं काम आहे. बघ आता हे माहितीये, हे झालंय आधी, बस तोच बेस आहे. सी फर्स्ट हा इकडे गेला, देन हा इकडे गेला. ह्या पॉइंटला येऊन तो उलटा करतो. हा आम आधी वरती जात होता ना, आता तो खाली गेला. दिस इज द वन ऑसिलेशन. एक पॉझिटिव्ह सायकल, एक निगेटिव्ह सायकल. ठीक आहे, शोधा आपण. सी टॉर्क आणि करंट. It will be very interesting to apply the results of all the above sections to a current carrying loop. You have learned about this electric motor in the previous standards. An electric motor works on the principle you have studied in preceding sections. नाही आठवत आहे? इलेक्ट्रिक मोटर रिड्यूस होतं. क्लिअर. आता जे सांगितलं तेच त्याच्यामध्ये यूज केलं. So that is magnetic force on a current carrying wire due to magnetic field. And diagram 10.10 तीच एका जी मी आता सांगितली. मला 3D मध्ये खूप चांगलं समजवत त्या डायग्राम. म्हणजे डायग्राम काढताना तुम्ही तशी काढा. It shows a current carrying loop. Let's say A, B, C, D. मी जे सांगते ते सगळं डायग्राम मध्ये शोधायचं. In a uniform magnetic field, so there will be therefore magnetic forces Fm acting in opposite directions on the segment of the loop AB and CD. AD and BC will get cancelled. Those forces will get cancelled because in that cases the direction of the current and field is parallel and divided. So there are two arms AB and CD. This results into rotation of the loop about its central axis. आता मी दाखवलं तुम्हाला फोन रोटेट करून कसं एक्झॅक्टली कॉइल रोटेट. Without going into the details of contact carbon brushes and external circuit, we can visualize the rotating action of a motor. नाही जायचं डिटेल मध्ये. We just want how this rotation happens in the motor. So the current carrying wire loop is of rectangular shape and it is placed in the. तेव्हा तुम्हाला हा फॉर्म्युला माहिती नव्हता ना, V bar cross V bar. So we have to study the same topic but in accordance with the Lorentz force. Yes. Because V bar cross V bar is the direction of the force. V bar is in this direction. This is V bar. This is V bar. V bar to V bar. जेव्हा हा मूव होता at the same time this will move. So see, the current carrying wire loop clear is of rectangular shape and is placed in uniform magnetic field in such a way that segments AB and CD of the rectangular loop are perpendicular to the direction of the magnetic field, that is V bar. That is clear. We can use the equation 10.14, means this magnetic force Fm is equal to I into L bar cross B bar, to find out the direction of the magnetic forces. So let's now look at the action of rotation in detail. For this purpose, you have given the diagram, following diagram. त्यांनी तो 3D मध्ये दाखवायचा प्रयत्न केलेला आहे, पण त्याच्यापेक्षा बेटर जे मी तुम्हाला आता समजून सांगितलं ते लक्षात. So the diagram is showing you rectangular loop A, B, C, D. This line. That horizontal lines this side, those are the directions of the magnetic. असं खाली. So it is placed in uniform magnetic field B bar such that sides of AB and CD are perpendicular to field, but the sides BC and DA are not. This BC and DA are parallel and anti-parallel, so we will not consider those two sides. Now we can calculate the net force and net torque on the loop in situation depicted in both the figures. Let's now obtain the forces on all sides of the loop. We already तुम्हाला सांगितलं दोन sides वर. What is this F4? F4 is the force acting on the fourth side. The diagram बघा 10.11. F1 is the force acting on side CD. Okay? CD. 10.11 मध्ये बघा. CD. F1 is CD. दिसलं का? 10.11 मध्ये. F2 is the force acting on the side AB. F3 is the force acting on the side AB. AB. And F4 is the force acting on the side CB or BC. Clear it? Which forces will get cancelled? F2 and F4. Now see. F4 you have given I into L into B into something sine of 90 minus theta, because theta is not confirmed. तो rotate पण होतोय ना. So the equation 10.21. Yes.
D च्या पुढं
मी तर हे theta is horizontal है. Now this is the angle between horizontal and this shape. That is your theta. Okay? 3D मध्ये दाखवायचं आहे. So F4 is now I into L2. L2 is the length of the arm. CB. B. Into sine of 90 minus theta. So theta is angle between normal and the magnetic field. We have to cancel out, but later on. We will first consider the two forces. Next, the force F2 on side 2, that is dA, is equal and opposite to F4 and both act along the same line, so F2 and F4 will get cancelled. काहीच गरज नव्हती द्यायची. Next, magnitude of forces F1 and F3. ठीक है, on sides 3 and 1 is IL1B sin 90. Sin 90 is maximum, that is 1. It will be I into L1 into B, right? Right? So now these two forces do not act along the same line, so they produce a net torque. It is not along the same line. These forces are not along the same. These forces are along the same line, parallel and anti-parallel. This force is in this direction. This is in this direction. So the two lines, it is in the same plane, you can say, but it is not acting along the same line. So hence it will produce a torque. Torque is a force with a couple or two forces are acting on the same time. So this torque results into the rotation of the loop, so that loop is always perpendicular to the direction of B, that is magnetic. So the moment of arm is 1/2 into L2 sin theta. Kutunala diagram 10.12 trigonometry se use karo. Movement of the arm is 1/2 into L2 sin of theta. L2 is the smallest distance. Yes, that one. Yes. Opposite side. This is movement of arm. Movement of arm. The movement of arm is 24 but half of this. Because it is a movement. It is half of L2 of side. See. This is given in diagram 10.1. Right? 10.12. This much is your L2. Okay? This angle is theta. This angle is theta. Okay? This is your movement of arm. Yala parallel karte. Now this is 90 degree. So for this theta, opposite side is L2. And this is hypotenuse, that is movement of arm. Arm is going to move in this direction. So movement of arm for this sin theta will be opposite upon hypotenuse means movement of arm. So movement of arm is L2 upon sin theta, but half of that, not total. Okay? So it is 1/2 into L2 sin theta about the central axis of the loop. This is for the total. Okay? The central axis साठी movement of arm means this much will be half of L2 into sin of theta. मग टॉर्क काय असतो? टॉर्क is force into displacement. Displacement is moving. Moving means the moment of arm. So torque will be, the total torque will be THAWAN plus THAW2. ठीक है, THAWAN means तो first arm होता, let's say AD तो तुम्हाला दिला, and THAW2 will be the second arm, torque due to the second arm. Torque is force into displacement. Force for this is I, काय होती length, L1 का L2, दोन्ही side, L1 B पुढे sin theta, you don't know the theta because at every point it is moving, okay? Into this is the force and movement is 1/2 into L2 sin theta. Same for the toe 2. It will be half plus half, that is 1 I L1 L2 B sin square theta की sin theta addition करायची sin theta, right? I L1 B sin theta into half L2 हाँ प्लस दिस, ठीक है. sin theta डबल नाही लागणार आहे मोमेंट ऑफ आर्म मध्ये घ्या. So half I L1 L2 B sin theta plus half I L1 L2 B sin theta will be 1 I L1 L2 B sin theta. This is the torque. I into L1 into L2 into B into sin of theta. What is this L1 into L2? L1 into A2 will be area. ठीक है. So this torque is for the one winding. For the number of windings, toe dash will be n into toe, that is n into I into L1 into L2 is A B sin out. This is the torque on a current loop for n number of turns, where B is magnetic field and A is area of the loop, whatever the shape of the loop is. I'm repeating, this is the torque acting on a current loop for n number of turns, having current I flowing through it, and its area is A, placed in magnetic field B, having angle theta between, that is current and magnetic field. Current and magnetic. ठीक है. एरिया मध्ये घ्यायचं ना, एरिया each time वेगळा. So toe dash is equal to NIAB sin theta. मग ते याला एक शॉर्ट फॉर्म ठीक आहे. मग कुठली टर्म राहत नाही. इट इज बी ना EIN होतं का कोणी आहे का You cleared with this? Torque acting on a current loop is NIDA sin of theta. There will be number of numericals based on this formula, and this is very important. Clear? Next is moving coil galvanometer, well known to you. So in previous topic, current electricity, we have studied about what is exactly MCG, that is moving coil galvanometer. What is its role when it is connected in the electric circuit? काय असतो हा MCG? त्याचा सेटअप कसा आहे? It is placed in horseshoe magnet, right? It has a coil now having number of turns and having one arrow, that is your arrows pointer, which is pointing on a circular scale. So at the center there is 0. On either sides there are some measurements. So by its deflection we can find out the amount or magnitude of current. The greater it will deflect, the greater will be the current. If it is deflecting on either side, then the direction of the current is changed. So we have studied about MCG. How will you convert this MCG into galvanometer, MCG into voltmeter? What are the different ways or the steps to convert this into ammeter and voltmeter? So in order to convert it into voltmeter, you have to increase its capacity of measuring the potential difference, right? That is to decrease the current. That is to increase the resistance. So we have to connect resistance in series. ठीक है. चला आपण X ने डिवाइड. हा व्होल्टमीटर. अजून नाही आला शाळेत. पुढे बोलते ना मी. In order to convert MCG into ammeter, we have to increase its capacity of measuring electric current. That is, we have to decrease its resistance. So resistance decrease करायचा, current capacity increase करायची, but the device should not be damaged. So we will give a alternating path for the current to flow, that is called as a shunt. As we have to decrease the resistance, shunt is the resistance which is connected in parallel with the original circuit. That is the galvanometerचा resistance का parallel, which is called as a shunt. झालं रिवाइज. त्यातला हा जो डिफ्लेक्शन वाला टॉपिक होता ना, हाऊ दिस डिफ्लेक्शन अकर्स किंवा करंटला कसा प्रपोर्शनल आहे, इफ द करंट इज twice the initial one, what happens with the deflection? Only that much we will study here. So there is only one formula related with the deflection, here denoted as phi, and the current, that is I. So what is the proportionality of the phi and I? You know that it is directly proportional to the current, but what are the different constant of proportionality? We will see. ठीक है, कशा कशावरती टॉर्क प्रोड्यूस करतो. Okay, moving coil galvanism. A current in a circuit or a voltage of a battery can be measured in terms of a torque exerted by magnetic field on a current carrying coil. So analog voltmeter and ammeters work on this principle, and here you have given the diagram which is showing you the cross sectional diagram of a galvanometer. ठीक है, actually तो person moving coil galvanometer. Okay, so there are two magnets N and S. Soft iron core is placed between the two magnets, and on that soft iron core there is a spring having n number of turns. Okay, so it can rotate easily on a coil. That coil can rotate easily, and at the center there is a spring which will allow the coil to rotate easily. And from that coil, one pointer is there which is pointing on the scale. तिथे होती तिथे त्याच्यापेक्षा अजून जरा सांग. That N and S is a permanent magnet. Okay, so it can be produced using electromagnetism. ते पण काय असते, that is the magnet. N and S poles, it is hard. Clear the diagram? It consists of a coil of several turns. It can be a number of turns, mounted or suspended or pivoted in such a way that it can freely rotate about its axis in a radial uniform. Radially, it can easily. So a soft iron cylindrical core makes the field radial and strong. Coil rotates due to torque acting on it as the current flows through it, and this torque is given by the previous one. Now see, what is this radial field? Radially increase झालं पाहिजे, म्हणून जे magnet आहेत ना ते असे नाही ठेवले. They are to produce the radial. Circular बनतो ना, field is radial along the radius, circular. ठीक है, so तसा shape तसा. And मध्ये soft iron core is in the circular direction. There is a coil, and at the center there is a spring. Clear? Now the torque experienced by this coil is given by tau is equal to same this formula NIAP. Now see about this theta. Current and magnetic field. Magnetic field is in horizontal direction. Current is in circular direction, radial. So at each and every point, current is perpendicular to the field. So here theta is 90 degrees, sin 90 is 1. It is NIAP. This is the
one with the magnetic field.
Field is this. असा फिरतोय, वरती चाललाय
हाँ.
परपेंडिक्युलर असं चाललंय. इट इज इन 3 डायमेन्शनल.
हा असं जातोय पण असा होता नाही.
फील्ड क्रिएट झालेलं सर्क्युलर. ऍक्सिस चेंज करतात ते. हा जर झेड ऍक्सिस असेल तर रेडियल फील्ड विल बी इन एक्स अँड वाय फील्ड. ठीक आहे, अदरवाइज इट विल बी पॅरलल ॲट 2 पॉइंट्स अपर अँड लोअर. तेच म्हणतो. हां, समजा असा आहे फील्ड तर इट विल मूव्ह. सपोज असा मूव्ह होईल अँड पॉइंटर इज 2 डायमेन्शनल डायग्राम. So tau is equal to NIAB, N number of turns in the coil, I current flowing. ठीक है, A area of the coil, B magnetic field provided. So A is the area of the coil, B is the strength of the magnetic field, N is number of turns. Number of turns I am repeating. कारण अजून एक टर्म येणार आहे त्याला आपण म्हणतो नंबर ऑफ टर्न्स पर युनिट लेंथ. डोंट गेट कन्फ्यूज. आतापर्यंत आपण कुठे आहे, नंबर ऑफ टर्न्स, दॅट इज कॅपिटल N. Throughout 12 capital N is number of turns only. I'm repeating in several times. कारण तिथं गडबड केली तर answer will come. Where capital N is number of turns of coil and I is current flowing. So here sin theta is 1 and field is radial. So plane of coil will always be parallel to the field. And however this torque is counterbalanced by a torque due to spring fitted. आता आपण काय करतो? Every time we try to balance the forces. So here one of the force or torque is this. This will be balanced by the force by the spring. आणि स्प्रिंगचा फोर्स आपण कन्सिडर करणार आणि तो कॉन्स्टंट कन्सिडर करणार and we will try to balance the forces. So this counter torque balances magnetic field so that fixed steady current I in coil produces a steady angular deflection. And obviously larger the current, larger will be the deflection. And larger will be the torque due to the spring. So if deflection is phi, restoring torque due to spring is equal to, if phi is the deflection, then restoring torque is K into phi. What is this capital K? Capital K is torsional constant of the spring. It depends on the properties of material of the spring. Spring कुठल्या मटेरियलची बनते? That is the torsional constant. Torque कसा देऊ शकते ती spring? जेवढी जास्त तुमची वायर जाड तेवढा तो torque जास्ती नसला. Yes. नस जाड असेल तर easily it will not move. It will not provide any torque. Yes, yes. Spring ची thickness. Torque easily नसणार आहे ना. आणि प्रॉपर्टीज आता त्याचं मटेरियल कुठलं आहे which can rotate easily so it will have a greater torque. So this is torque experienced by a spring where K is torsional constant and this was torque initial torque of the rotation. Yes. हाँ हाँ yes 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 center line spring आणि coil move होतो. काय बोलली? हां 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 बॉल पेन मध्ये असते ती स्प्रिंग सेंटरला असणार आहे ती मूव्ह करायला त्याला परमिशन देते आणि कॉइल इज मूव्हिंग स्प्रिंग सेंटरलाच ठीक आहे फिक्स 3 डायमेन्शन बघितल्यावर अजून जास्त क्लिअर. This is torque experienced by the total coil. This is by the spring. Both will be counterbalanced. So we are going to equate this K phi is equal to N I A B. We are interested to know about the deflection. ठीक है deflection कशावरती depend है. So phi will be N I A B upon K. So from all these terms, N is constant number of turns. It will not change. Means deflection number of turns वरती सारखा change नहीं होगा. It will be constant. Area is constant, field is constant. This is the constant. This is changing. So hence deflection is directly proportional to the current where all of these quantities are constant. N A B upon K. ठीक है? So you can conclude the deflection phi is proportional to the current and modern instruments use digital ammeters and voltmeters and do not use such MCG. But I still don't know की अजून syllabus. Maybe ते तुम्हाला वर्क किंवा फंक्शन समजण्यासाठी. But आता आपण ammeter voltmeter असं नाही यूज करत direct digital आता. They will give you the values. तुम्हाला calculations करायची गरज नाही. येऊ शकतो नंबर ऑफ टर्न्स कॉइल 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 स्प्रिंग फक्त मूव्ह करायला अलाउ करते. किती जास्ती मूव्ह करते. दिस इज द कॉइल दिस इज द स्प्रिंग इथे आले पॉइंटर कॉइल इतकी मूव्ह झाली पॉइंटर तितका. This is only allowing it to move radial. Now, coil it is made up of number of turns. तिथं मग suppose तुला 5 दिसतात lines दिसतात actually. अजून एकच point. क्लिअर आहे? मी ना हे 1-2 चॅप्टर्स होते जे जे मी तुम्हाला असं सांगितलं ना 3 डायमेन्शन मध्ये जास्त क्लिअर होतं. बेसिकली पार्ट 2 मध्येच हे सगळं येतं. मी त्याचे थोडे व्हिडिओज कलेक्ट करते बघून आणते. आपण तिथे लावून बघूया. खूप छान क्लिअर होतं. किंवा तुम्हाला प्रोव्हाइड करते, तुम्ही बघा तुम्हाला वेळ असेल.
नाही नाही तुझं answer. कधी नंतर करू.
So next is magnetic dipole moment. In electrostatics, we have studied everything, that is force, potential energy due to a single charge, due to a two charges placed at a particular distance, due to two charges with a fixed distance, that is dipole, then single charge in uniform external field, two charges in uniform external field, and dipole in uniform external field, right? मॅग्नेटिझम मध्ये और मॅग्नेटोस्टॅटिक्स मध्ये कुठेच तुम्हाला असं दिसणार नाही मोनोपोल, बिकॉज फॉर मॅग्नेट मोनोपोल डझंट एक्झिस्ट. सो इट ऑलवेज will be due to dipole. So here we have to find out the magnetic dipole moment. तिकडे होता इलेक्ट्रिक डायपोल मोमेंट. कशाने डिनोट केला होता? P bar. P bar is equal to Q into 2L, that is charge into distance between them. ठीक आहे. आणि टॉर्कचा एक फॉर्म्युला होता, टॉर्क एक्सपिरियन्स्ड बाय डायपोल when the dipole is placed in the electric field. Tau is equal to P bar cross E bar, right? In this section, in magnetism, we again have this magnetic dipole moment. So here, magnetic dipole moment denoted by mu. आठवतंय काय फॉर्म्युला? म्यू no mu, magnetic dipole moment, that electron revolving I told you. Yes, म्यू ची व्हॅल्यू नाही बाळा, मॅग्नेटिक डायपोल मोमेंट म्यू. इलेक्ट्रॉन रिव्हॉल्विंग इन द सर्कल साठी म्यू ची व्हॅल्यू काढली होती, जे तू विसरत होती 2 वेळा, म्हणून परत विचार. मॅग्नेटिक डायपोल मोमेंट, that is mu naught. Permeability is different thing. This is magnetic dipole. Both are denoted by mu. Current into area, तेव्हा magnetic dipole. इथे होता चार्ज, here it will be current. ठीक है? This is in 2 dimension, so length is fixed. Here it will be area. तो पण शेप असेल तुमचा तेच एरिया, सर्कल असेल, स्फियर असेल, व्हॉटएव्हर इनटू एरिया. इथे टर्न्स वगैरे असे काही नव्हते. हियर इट कॅन बी नंबर ऑफ टर्न्स ॲज I current is flowing into the wire, so wire can have number of turns. This is for single turn and this is for n number of turns. Usually try to write all the formulas in number of turns. So if it is not given, then it is 1. So substitute n is equal to 1. दिला असेल तर गडबड होते ना, त्याच्यामुळे n च्या टर्म्स मध्ये. So this is now magnetic dipole moment. कसं लक्षात ठेवायचं कळालं? चार्ज, करंट, लेंथ, एरिया. इतर टर्म्स नव्हते, तिकडे सगळीकडे नंबर ऑफ टर्न्स. So that is your magnetic dipole moment, n into I into. Everything try to remember by comparison. तर खूप इझी जाईल, नाहीतर खूप लक्षात ठेवा. ठीक आहे. सेम टॉर्क एक्सपिरियन्स्ड when dipole is placed in external electric field, torque experienced when magnetic dipole is placed in external magnetic field. It was P bar, it is mu bar. इधर E bar, इकडे V bar. काही फरक नाही. सेम बघा तुमच्या बुक मध्ये. In preceding sections, we have dealt with current carrying coil, and this current carrying coil can be described with a vector mu bar, that is its magnetic dipole moment. गडबड नाही करायचं mu मध्ये. If n cap is a unit vector normal to plane, then direction of mu is the direction of n cap. So we take the direction दिलेली, the direction. Vectorial approach they are considering. So we can then define magnetic dipole moments of magnitude by mu as n into I into n. Where n is the number of turns, I is the current passing through coil, and A is the area enclosed by each turn of the coil. So we are multiplying it by the number of times. Okay? If held in uniform field, torque will be responsible for rotation. So it is mu into b into sine of theta. That is mu bar cross b bar. ठीक है कंपैरिजन मध्येच लक्षात ठेवा बाकी थोडी नाही लागत सो टो बार हियर was p bar cross e bar here mu bar cross b bar dipole moment is substituted at the same time electric field is replaced by the magnetic खरे डायग्राम मध्ये दिलेलं आहे मॅक्सिमम मिनिमम पण ते याच्यासाठी लागत नाही तर 10.9 साठी लागतं तिथं का दिलं नाही dipole moment related is our next topic but still I'll take this in next lecture read करायचं we have 15 minutes more So see, first topic होता magnetic force on a wire carrying a current. First check right over there, state y. ठीक है? Then F bar is Q into V bar plus V bar. Here velocity is drift velocity because at every point they can change the direction also, either linear. Drift is direction and speed is changing at the same time and each and every point. So it will be Q into V bar cross V bar. Charges are not given here. They are current है ना, म्हणून first you write this one, then this force, then the formula, and up to this only. This equation holds true when theta is not given. Otherwise, directly I into L into B. याच्यामध्ये एवढे छोटेसे डायग्राम म्हणून for arbitrarily shaped wire, you have to just integrate it. So for small, it will be integration of Fm, small amount of force is dFm for dl, and total force is integration of d. ठीक है, छोटासा शेप. Closed loop साठी एक मोठा स्टेटमेंट लिहायचा. Magnetic force acting on a closed loop is always equal to 0 because if the provided magnetic field is uniform. Provided magnetic field is uniform. कट कराने के लिए. Torque on a current carrying loop. ठीक है, टॉर्क साठी जो इलेक्ट्रिक मोटर वाला केस होता तो आठवायचा. त्याचा डायग्राम शॉर्ट मध्ये काढायचा. देन F1, F2, F3, F4 forces consider करून 2 will cancel out as the direction will be parallel or anti-parallel. Rest of the 2 will create a torque because they are not acting along the same line. This is the main reason. So total torque is τ1, τ2. Draw this short diagram. त्याचं addition करा. अजून एकदा एक टर्म येणार आहे. Total 2 will be I, L1, L2, B sin theta, where L1, L2 is area. These two steps. मग खाली लिहा E is theta and sin degree. This is totally perpendicular. Then काय? एवढं. Next is MCG, moving coil galvanometer. Draw a short diagram and just this proportionality. ठीक है? This is torque experienced by coil and this is by the spring. It will be provided by itself. So both will be equal and we will find out its proportionality. And last will be magnetic dipole moment. Just write the dipole moments in comparison manner for electrostatics and magnetostatics. So electrostatics से revision हुई, magnetism clear. आहे का सेम टॉपिक?
डायग्राम भी सॉर्टेड है.
काही
CBSE ला करून मला
Now you have MCG in 2 lessons. Current electricity मध्ये ammeter, voltmeter. They have MCG only once. ठीक है. त्याच्यामध्ये ammeter, voltmeter, deflection, everything is included. ठीक आहे. But they don't have that diagram to convert into ammeter or voltmeter. छोटेसे diagram. So ते clear नाही होत. What are the basic steps to convert it? They can get confused. आता बघ तिथं डायग्राम काढली दिसते का? त्याच्या खाली, त्याच्यावर केवढीशी वेगळी. they have electrostatics in 2 levels, first and second. Potential is different thing and capacitance is different.
म्हणजे त्यांचं 11th इलेक्ट्रोस्टॅटिक नव्हतंच का?
नाही. 11 तुमचं इलेक्ट्रोस्टॅटिक्स त्यांना फर्स्ट लेसन.
म्हणजे तुम्हाला नीट आणि जे